as it's happening, the ice that's around that, the glacial, the stuff that moves. Now this is very slow moving glacier. It's almost Piedmont Glacier is what it's called, which is sort of in the flats, okay? The flats mean that it's actually just a very shallow slope. So that's slow moving, but moving nonetheless faster than it used to. I'm going to jump here a little bit. There's the Arctic. Now the Arctic is extended ice. It's all floating, okay? Contrary to the rumor or the story that my young 7-year-old grandson told me, that the reason you can't see Santa at the North Pole is because the whole setup is below the ice. And I said, boy, he's going to be really wet. Okay. So two things have been happening here. That's taken at the same time of year, and over a long period of time, over the last 100 years, what's happening to the extent ice? Not only is it getting smaller in area, it's getting thinner. We used to be able to do ice cores there and have pretty consistent measurements in deep ice that went back many years, and they call that the old ice, okay? The ice of some ancient times. But in fact, there's almost none, or there's very little of the old ice there. And new ice is much more sensitive to the changes in temperature and the surrounding area. Another thing that happens, because you open up that much water, what used to get reflected, the light that used to get reflected into space, back out into space, is now absorbed in a greater part by the ocean water around it. And that helps to heat the ocean water. Now, not just that, but currents, bringing up warmer currents, the change in the global temperature of the seas is smallest at the equator, but extensively greater at the poles. In other words, maybe a half a degree or so around the equator, maybe even a little smaller than that, but 10 degrees, 12 degrees by the time you get to the poles. So it's actually, it's weird because it's affecting the ice areas greater than it affects the areas around the equator. Notwithstanding the fact that some of the southern areas, like the Peruvian glaciers, are also melting. And I've got some pictures of that. I'm going to go on through here for the sake of time. And check these pictures out. Okay, this is Peruvian Andes from 1999 and 2014. These are pictures that have been collected from people who took pictures of the ice areas. I got a set of these, but here we are. We're looking at 15 years, and the ice was on the left, which you saw was 1999. This is what's left in 2014. Okay, it's easy to say that's just unusual. It's that area, big deal. Okay, but is it just that one area? This is Peru. Let's see what else. This is what got me started again. Okay, this is the Pasteers Glacier, and this is Austria. This is the Alpine area. Okay, look at the changes in the glacial movements. This down here are called glacial ponds, and that's water where ice used to be. Okay, how long was that? 2004 to 2014? Come on, 10 years. That kind of change has taken place. When this stuff happens, there are positive feedback characteristics. Positive feedback is that which reinforces the motion that has begun. And so what you see over time is that this change is very rapid, much more rapid than we would have guessed. And if you read the reports in 1990, 1980, where there are already people talking about global warming effects, okay, nobody predicted that rate of change, especially what we saw in the Arctic. Okay, that's just the Mueller ice shelf in the Antarctic, but all this unfortunately doesn't have a contrast. It just shows what it looks like when the extent ice is breaking up. But let's take a couple more of these. Okay, this is in the Cordillera Blanco area of Peru. Again, the Peruvian, and a little bit better picture of this area, showing a little bit better picture in 1986. The other one was earlier, right? Or later. 1986, what the glacial ice. Remember, all glaciers are moving, right? If it's called a glacier, it's because it's in motion. And so that's 86 to 99, and you can see a very dramatic, and here again, in the bottom here, there's that glacial pool forming from melted ice. 75% of the glacial ice around the world has been lost in the last 60 years. Lost, I mean melted. Okay? Now somebody will tell you, wait a minute, some are melting, some are actually growing. And that's true. 7% are actually in a growth state. Okay? There are variations around the globe. Okay? Climate is not a consistent thing. Remember, climate is measured globally, not locally like weather. So it's possible to get variations in all of this. Okay? Grinnell Glacier. This was my experience right here. This is Glacier National Park. Y'all can visit this. How many people have been west in these areas? Anybody? Some? Have you been to this part? Yellowstone? Yes. Okay. Yeah, all right. Worthwhile. I find a surprisingly number of students. I've been teaching here Dr. Marshall back here has been here, what, 16 years now? Yes. Okay. What percentage of our students would you guess have ever visited the West? Pretty small, right? Get out there. It's the best part of this. Well, I mean, it's interesting. Okay. All right, enough of that. Okay, well look at here, here's Grinnell. That's what it looked like in 1911. I saw it in 1961, and I don't know that I could make the comparison between those two. I just saw a lot of glacial ice, okay? So, but that's what it looks like, and that's what it looked like in 2009. So even what's left there has probably receded a bit more, okay? We just have never seen changes occur at this rate. So anybody says it's just a normal cycle, forget that. Forget that. There's no way that we have ever seen this kind of change at this kind of rate. Again, back to the alpine area, Maureen, that one's called the Elephant Foot Glacier. You guess you can see why. It's called a moraine glacier, actually. So the slope has been very steep down there, but then it gets down to the Piedmont, gets down to the bottom area and spreads out and forms that kind of an appearance of an elephant foot, okay? That's what it was in 1859. This is what it is in 2001, and you can imagine even now further going, all right? Talking about glacial changes through a 100-year period is ridiculous. It's ridiculous. You'd be talking about 10,000 years to see a measurable change. Now we're seeing it in less than 100. Something in the last 100 to 150 years made the difference. And so any scientist worth their salt would say, that's the observation. That's what we're seeing. We've got the measurement. Now, we've got to conjecture why. Hypothesis. What could it possibly be? Changes in solarity, which is the incidence of light from the sun, energy from the sun. It could be changes in our orbit. It could be changes in precession. Okay? It could be other changes in the atmosphere, whatever. Okay? As we rule out volcanoes, at one time it was volcanoes that were causing it. As you rule each one of those out by scientific means, okay, you get down to the one that can't be ruled out, and guess what? Okay, greenhouse gases, which includes CO2, methane, nitrates, and sulfates. Now, interestingly enough, the last one, the sulfates, actually go the other way. They actually have a cooling effect. So if we had an equal effect from both the sulfates and the CO2, okay, we'd have a terrible atmosphere, but the temperature would have remained constant. All right? We actually did see that in the 40s. Some people will say, how come it actually got a little colder during the 40s? And that was because of the sulfates that we were producing by quantity. All right, so there again, past years, that's a better picture. That's the open area in Austria. You can see again, very dramatically lost in glacial ice. Okay? Out in Nepal, I said it's worldwide. This is going on all over. Okay? So here we have the Nepal area called the Langton region in Nepal, the Yala Glacier area, again, from 1996 to 2008. Okay? It's ridiculous that it's changing as fast. Okay? What's the result of some of that? Part of it's sea level rise. Okay? So again, we've seen the sea levels rise around the world disproportionately because of where the water is coming from that's being added to it and how much temperature change. Now, most of the rise is due to the expansion of the ocean waters because of temperature increases. Okay? Most of it at this time. A little bit's come from Antarctica. I have a slide here I'll show you a little bit later that shows you what the contributions are. But there is a genuine increase, measured increase in sea level. See, this is no longer computer projections. In the 80s and 90s, it was computer models that said that's going to happen. We didn't have a lot of physical evidence showing up, except the canary in the mine, as we might call it, some of this glacial activity that was giving us an indication that it might already be in progress. Okay? So here we got, now the chart is basically it's all the same here, different locations, but it's rise over the last 50 years. Here's the East Coast over here. This is Galveston, Texas, actually South Coast, and along the east. You see here's 12.5 inches there, 9.5 inches. West Coast, you get out to Los Angeles. Thank goodness for Los Angeles, because if that goes up another foot or two, and you get to San Francisco Bay and the LA areas and so forth, you're going to see some pretty nasty stuff. Governor of Florida, 5, 6, 7 years ago, was claiming he was another one of the deniers, one of those who said it ain't happening. Okay. Well, while it ain't happening, he's got his own state people, engineering people, and so forth, who are working on projects to protect the coastline. And he's got to protect the coastline. Just imagine, he's playing Netherlands. Okay, we got to put up the dikes. We got to build the break walls. We got to do something to protect the coastline because the ocean levels are up. So, Governor, why are they up? I don't know. They're just going up. So I got to protect myself against them. He's still in a denial state. You think about the reasons why anybody would look at the facts and still say it ain't happening. It's because they have a huge vested interest. In 1960, some of the major refineries in this country cost $5 billion. Okay, the ones that I worked at was Chevron on the South Coast, and some that I worked on the West Coast by Mobil before it was Exxon Mobil. Okay, $5 billion thereabouts to build a refinery, and once it's built, you just pump crude through that, and you can sell everything you get. Okay. Now, why in the world would they line up to say, we're causing a problem, let's shut down the refineries? That ain't going to happen. And the fact is, you don't want it to happen, right? Because you don't want your energy bills to go through the roof, okay? Something has to change, but it has to be very measured, very clever, very well thought out, and new technologies. And I've got some technologies to sort of post out there to you for possibilities. All right, let's keep going here. Mean sea level changes going up. You can see that this little insert here gives us just the changes from 1990 to 2005. There's 15 years of measured increase in sea level rise. Okay, I'm going to jump here to, that's the temperature, just showing the temperatures going up. If you look at this little flat, right in here was the measured time when the 40s where the temperature actually went down. And there were scientific types who were going around saying, we're heading for an ice age. It's getting cooler. Okay? Denying all of the previous information that we had that indicated, no, we're on a warming cycle. If you go from 1900 to current, you can see if you do a line up through that, a line of best fit for you statisticians, okay? It's definitely got a major positive slope. Positive correlation. True? All right, here's the sea level rise. What's happened so far? This is up to 2014. Okay, well, there's Antarctic. Those are in millimeters per year, which doesn't sound like very much, right? But they're growing. So you get only a quarter of a millimeter per year going on from the Antarctic. That is because the ice that's melted there so far is extent ice. ice that's already in the sea doesn't add to the level, right? It's like an ice cube in a glass of water. It's not going to do much to do that. But start adding melted ice into the glass, you can overflow the glass of water, obviously. Glacial melt, okay, is actually 1.5 times, roughly, of what's been going on from Antarctica, but we've known of that for quite a long time. That's had a lot more years to occur, but that's millimeters per year, so the effect is somewhat dramatic. There's Greenland. The ice melt in Greenland is dramatic compared to the history records. Okay, and that's happening throughout. A very strange things happen in the surface ice during the summertime. Let's say during the time when the sun's rays are more direct, we get pools of water on the top of the ice. You get little pools of water, and that'll gather, and then all of a sudden they'll disappear. They just, in a matter of hours, are gone. And what's happening is that water is melting water or ice that's just immediately below it. It goes right down through the ice. It's like drilling a hole through the ice. Ends up at the bottom of the ice, and all of that water simply flushes down to the bottom. Well, now you've put water underneath the glacier, which means the rate of change, the rate of slope is now, the rate of motion is now faster. And that's one of the reasons that we're seeing Antarctic ice moving 10 times faster than it used to. All right. Expansion from ocean warming. Right now, that's the most dramatic effect. That's what's driven this 12 inches of water predominantly along our east coast. Now you think about it, you do the variations in the water in the ocean as we go through our natural cycles. And then add on top of that possibly high winds, hurricanes, those kinds of things. The hurricanes have the effect of literally lifting the level of the water up. So if you've raised the water a foot already, and then you add those other dramatic effects on top of it, you've got severe erosion around the shores. There are islands where people have to leave now, South Pacific islands, people have to leave the island or move to higher ground on there simply because of all the erosion going on around their island. Okay? Let's see, that's a good one, but I'm going to skip it for now. Okay, there's the long wave. This is what we get from the ice cores. Okay? 800,000 years. Okay? Can we get that information reliably? Yeah, I mean, you get 3 or 4 teams down there who are sampling ice in different areas, getting the cores out, cutting them, doing the measurements and so forth, and you get a lot of correlation across this. But look at, those are the natural cycles. Okay? There's a shorter, you can see the shorter waves going on then. Those cycles tend to be around 900 years, okay, 1,000 years, something like that. That's what Singer, when he wrote Unstoppable Global Warming, that's what he claimed. It's just one of those natural cycles, okay? But if you look at the long wave, look at the peaks, and then look at the CO2 over here, there's 300 parts per million at the top. The average has been around 240 or 250, plus or minus 50. Okay? Now, what in the world makes changes like that? Those are pretty dramatic. And the answer is that the orbit of the Earth is elliptical. Okay? It's not a perfect circle. You take that ellipse, and over time, if you could sort of look down in that ellipse in a sort of time-sampled photographs, if you will, okay, you would see that ellipse tend to rotate. Okay? The long axis of the ellipse would tend to move in a circle over a very long period of time. We're talking about 100,000 years. On top of that, you got the Earth, which precesses, right? We wobble. We're a spinning top in space. And the combination of that wobble and the elliptical changes, we didn't need people around to make those changes. Those happen naturally. That's the cycles that we get from that. And so you can see over the last 800,000 years, natural cycles, CO2 never higher than 300. That's a bit of science. I debated putting this one in here. Whoops. Why doesn't that show? Oh, there it is. Okay. I'll just point out this one. These peaks in here if you know liquids and, thank you, liquids and gases can be determined in terms of their content by absorption techniques, by what wavelengths electromagnetic radiation they absorb. And it's very accurate. They're fingerprints. You can tell exactly what composition of gases, for instance, are in a collection of gases like the atmosphere. Okay? So this is not hard. What's happening is we're finding it's the lower infrared that has the absorption frequencies and wavelengths for the CO2. Okay? You get up around light, which is up in this region here. And so this is where Homer-Drummond said, light comes in, but the CO2 is transparent to the light, okay? But it's opaque to the infrared coming back out. That's how it absorbs the energy, and that's what causes the temperature effects and changes in the climate, okay? There's the famous hockey stick. Boy, did they pick out a bunch of people for this one, all right? But there it is, and that's over the last 1,000 years, and look at that. In this interglacial period, you get some times where things level off. Things are relatively constant for certain periods of time. That's an example of it. And here we get to the 1800s, Industrial Revolution, and look at this. This rise. We're up to 410 parts per million now, which has never occurred in the last 800,000 years. Okay? That's kind of a dramatic example of the famous hockey stick put up against the long wave. Okay? I don't know. Put in there for drama, I suppose. Okay? Let's see, I think we beat that around pretty good. Okay, who's supplying this and why? Well, look, this is the increase that we've had since, what is that, 1924 in our use of electricity. Okay? We have a voracious appetite for energy, and it's going up. A third of that, let me show you that chart. A third of that energy comes from coal. 33% comes from the burning of coal. Coal probably, and China now is trying to get off of, if you read the news from China, the current events, they're trying to get out of the coal-fired energy plants over there because it has messed up their atmosphere to such a great degree. It's not just carbon dioxide in the water. It's the soot and all the other stuff that comes from those plants. Very dirty. You probably heard during the Olympics when they had the Olympics over in China that they had to shut those plants down in order to clean the air around the city. Okay, so that the foreign visitors wouldn't realize how dirty the atmosphere was. Natural gas, there's a strong move to try to move to natural gas. It's cleaner than coal because of the impurities it doesn't put in the atmosphere. All right? It burns better, but still the output product of any fossil fuel that's burned is CO2 and water. And so whether it's natural gas or coal or petroleum or whatever, the output is still CO2 and water. All right? Nuclear, a lot of thoughts that this is going to increase tremendously. There are other difficulties with that. There's our hydropower, a fairly small percentage, and so on down the list. Notice these as solar, wind, geothermal, biomass, not a lot of contribution there. I'm going to show you, and I'm going to try to move as quickly as I can to it, some possibilities that are going to give us pollution-free energy in huge quantities. Huge quantities. We have the ability to replace the plants. The thing is, you don't just step change from one to the other. Your generation especially has to be part of the process that gets us from here to there over a controlled process. Not only your generation, but the one that comes after possibly as well, and more. Okay? I'm going to go to here. Now if this works, I hope. Let's see, there might be a couple of ways of doing this.
You could escape and minimize the presentation first before you click.
Sorry, I can't hear.
Escape and minimize the presentation before you click the link.
Can you join me here just a minute? I'll go back out of this one here. Okay, so here I am. This is probably the most important slide I've ever shown. Okay, bear with me just a second. I want to show this one right here. Hit that first. So almost to the bottom. That one right there. Yes, that one. Okay, I'll talk my way through it. All right, you've heard wind energy, solar energy, solar panels going in. The payback is still not quite there. Okay, there's a lot of possibilities. Here's the big one. We now have organizations, engineering outfits who have produced and are now installing, one's off of Canada, one's off of the Florida coast here in the States, an ocean-generated electricity plant. It looks like a wind generator, but in ocean current, okay? And it produces orders of magnitude more energy per unit time than the wind towers could ever think of doing. It doesn't take up otherwise useful land. But the big one, and the one I'd love to show you here, is a display that actually came from Toyota, okay? I have a little heartburn with the fact that America seems to have lost its desire to innovate, to be a leader in these things. So we get Honda and Toyota and some of these other organizations like hybrid cars, bringing them to the States, and then sometime 10 years later we catch up with it, okay? That's not the America that I remember growing up. America that I remember growing up, we were the leaders, okay? People followed us around. So the big one that's going to happen is they now have technology in place and working to convert ocean water using the ocean electricity that's coming from the ocean electric plant, okay? What is that? That's ocean currents, which are driven by what? The temperature, the sun, right? You can't get any kind of closer to the sun and direct source, and you convert that water with electrolysis, electricity again coming from the ocean itself, okay? And that produces hydrogen and oxygen. And if you check the technologies today, fuel cells and electric motors are just now beginning to replace gasoline engines in at least the cars. They're soon going to be there. Proterra already uses electric on their buses here in Greenville, okay? Your future, my prediction, is a hydrogen-based economy. We're going to be completely off of fossil fuels in 50 years. My prediction, I won't be around to see it, probably, but I hope. I'm a very old guy, no, seriously. But you will, you'll see it. And hopefully, with what you get from tech schools like this, if you get into whether it's engineering programs, business programs, or whatever, you're going to be major contributors to the change. Done in a controlled way that we don't destroy the economy to get there. Okay? That's it. Thank you.
We will be putting out a link with the recording from today and also the discussion panel on Monday, so that you can watch the videos if you want, and you can click on some of those links. And Mr. Federley will do this for me. We'll also provide his PowerPoint so you can actually go watch those videos that weren't working. Okay? So please come see us Monday. Yes, he'll be on the panel on Monday. Yeah. No, we're doing a panel discussion Monday with four of us. So we'll each talk for about 5 minutes, and then it's going to be Q&A type stuff for
I might
everybody.
rely on some excerpts.
Discussion with students being able to ask those questions.
What's your program?
This is Deshauna.
Bedtech. Okay, well, not directly.
Well, it sure will with the
We're going to be
animals that you're
saving,
going to work
we're
with.
going to be saving the animals in the future, right? Good for you. going after large or small? And we're gonna big farms?
Yes, so if you sign in on that sheet, we make photocopies for, make sure you put your faculty number.
Yeah, I put my teacher's name.
Thank you, that's what I was looking for, the name of your faculty member. Okay.
Because that'll get you to the world slates. Sir, come on up. My hearing is not working.
You're talking about the electric motor. I'm currently